from Disguise and Valinga, and I am going to hand it over to you, Addie. Tell us about some nerfs.
Thanks, Jess. Hello, everyone. So the two companies represented here, Valinga to my left and right, and I'm Addie with Disguise. We did an incredibly successful webinar just a few weeks ago on Nerfs. There's been a lot of interest on what it is, how it's used, and where it's going. So we want to share all this info with you. Super excited. So let's get right into it. Quickly going to introduce who I am. If you're in LA, you probably know me by now. I am the Vice President of Virtual Production with Disguise, and I'll go through what we do. To my left, I have Fernando.
Hi, Adi. Hi, everyone. I'm Fernando, co-founder of Bolinga, and also leading the product development of Bolinga.
And I have Orlando on my right.
Hello, everyone, and thank you for having me here. I'm co-founder of Bolinga and chief scientific officer of Bolinga.
And these gentlemen are from the Canary Islands. So we're a very exotic place. We're super happy to have them here in LA for Production Summit. And thank you, Jess, and everybody on the team for having us on stage. Excellent. So Disguise is a global technology company. We make a tech platform that powers, believe it or not, hundreds of VP stages, virtual production stages around the world. We have an incredible history with live events. If there is any big show on the planet, let's say a Taylor Swift or a Drake or a Beyonce, it's being powered by Disguise. We have also presence in broadcast. We power the ESPN stage. And if there's a big film shoot going on with the car process, chances are it's using a Disguise server. So that's who we are. And I'm going to go into Valinga, a little bit of history there.
Yeah, well, Bolinga is a startup which has been out from a Spanish company, Alchemia. What we do, or our vision is we want to unleash the power of Nerf, make everyone capable of use Nerfs. We provide now different seamless integrations for both creation and real-time rendering of Nerf in different softwares and different platforms. And yeah, one of them is Disguise. A month ago, we announced an integration with Disguise, which is having quite a good reception. And yeah, we're pretty excited to tell about it.
Very excited. So one of the key advantage to Disguise is it's the opposite of sort of like an Apple, like a closed ecosystem. We're actually a very open and widely, easily integrated ecosystem. We have hundreds of integrations, and the most exciting ones for us is obviously Valinga and all of the latest AI tech. So Valinga's SaaS solution drives right into our servers, which go right up onto a stage like this. So it makes it way, way easier for productions to actually use and harness the latest technology. Orlando, you want to talk a little bit about sort of the motivation and history of why you guys were founded and what your mission statement is?
Yeah, we started with Nerf in 2020. If you know, the original paper, scientific paper that published for the first time this concept was done by Google and the University of Berkeley. That was back in 2020. We spotted as very promising concept that was going to revolutionize computer graphics and the audiovisual sector in general. And we started to work on that, to research on that. So we are researchers. Our background is research and engineering. And yeah, we started in 2020. And for 3 years, we were researching different use cases and different challenges. And then at some point, that I guess we will talk about that later, we decided that it was the time to bring this technology. It was mature enough to bring it to solve problems in the virtual production domain. And that's how we created it, to bring this awesome technology to professionals and to put it in the hands of professionals.
Absolutely, and we interface with all of our customers and their virtual art department teams, and there is just a incredible need for photorealistic 3D environments and photorealistic content. And Volinka is, a excellent promise in supplying that incredible demand. So I'm gonna hand it over to Fernando to explain just at a very high level what a nerf is. So that'll sort of kick us off into this tech exploration.
Okay, so basically, we can think of a nerf as an AI that ingest different images, different 2D images from a scene. It can be coming from a video, it can be coming from different photographs. And this AI, these neural networks, learns how to represent the 3D content of the scenes. Not only the geometry, but also the specularities, reflections, everything. We like to see NEF as an intersection of machine learning because it's using a neural network, computer graphics because it's using a lot of computer graphics techniques and rendering techniques, and also generative AI because what we are doing is generating new content from existing one.
Yeah, one way that, this is a $1 million question. It's so different to conventional computer graphics primitives that is difficult for people to understand, even for ourselves when we started. And one metaphor or analogy to explain it is that this is, we use machine learning to learn the pixels in an image. So what you do is basically you take multiple pictures of a scene, and then obviously you take the pixels from those pictures. So now the neural network will have the task of learning what each pixel, the color of each pixel from the position and the orientation of the camera. So now once the neural network is built for that scene that was trained with those pictures of that specific scene, now that model, we can use it to ask for pixels from an arbitrary position of the camera. So now we can say to the neural network, give me all the pixels of an image for this camera in this position and in this orientation and with these properties, optics of the camera. You see, so we take the pixels of all those pictures and we train the model. And now you have a model that is going to be able to generate and imagine, so to speak, the pixels of an arbitrary camera, a camera moving arbitrarily in a 3D space.
I believe that's called a novel perspective, right?
Novel view synthesis, yeah.
Yes. So as a Nerf user, and I have been using Valinga to generate Nerfs, my best understanding of a Nerf, this is just sort of my expression, is it's a way simpler way to represent physical real worlds without doing the work. So I've used reality capture in the past. I've worked with AR and VR companies, and it's a lot of time, a lot of work, and it takes a lot of skill to get the right output. Whereas Nerves, the machine learning, the AI does a lot of the heavy lifting for you. So super excited about that. Excellent. And then it's also important to understand what Nerf is not, right? So walk us through some of those.
Yeah, well, one of the first things is it's not the next version of photogrammetry. If you are expecting to have, we are going to talk about it a bit later, but if you're expecting to have different materials, different textures, you're expecting to have polygons to work on it, it is not. This is a new, as Orlando said before, this is a new computer graphics primitive, and it's not photogrammetry, it's another new thing.
Yeah, Orlando, anything to add to what we should not expect from a Nerf asset?
Yeah, you cannot expect meshes. You cannot expect conventional primitives. And this is a little bit confusing because there are plenty of research and people trying to do a hybrid solution. So we have been thinking about how we can reuse all the computer graphics knowledge and techniques in this new paradigm from the scientific side, So there are plenty of experiments making this hybridization, so to speak, between Nerf and the concept of radial fields with meshes, with polygons, with voxels. So, but I think it's important to understand that this is a different thing. And then we will currently are doing research and engineering on understanding how we can use meshes and the role that meshes are going to have. For example, for relighting, it seems that they may be necessary. But Nerf is not a way of getting meshes, of reconstruction
Absolutely.
based on meshes.
This is the part that broke my mind the first time. I learned about Nerfs. So Nerfs have all the usability of a full 3D geometry photogrammetry, but with none of the weight, if that makes sense. There is no vertices, no meshes. Actually, there's no UV maps,
There isn't.
no textures, but it's everything a photogrammetry asset is without all of that complexity. It's so your brain has to almost work in a different way to use it. And the conventional things like, oh, I could just change the texture map. No, you can't. There is no texture map. Or I can optimize the geometry to run faster. There is no geometry. Things like that, right?
Exactly. And I also would like to explain that even though Nerf is awesome, I think we are still on research. We will talk about the limitations, and there is still some things that you have to take care about when you are creating, working, and capturing Nerfs. And that's what we say. It's still not the almighty 3D generation method, but yeah. it is
Again,
still
yeah,
awesome.
go ahead, Roland.
Yeah, I think we need to be very realistic and humble regarding Nerf. It's a 3 years old baby that is already running, which is quite surprising, but it's 3 years old. So there are hundreds of universities and research centers in private companies and public institutions doing research on it. So every year we get hundreds of papers in Nerf. So we are still figuring out how to manage this primitive representation, and there is a lot of work to do, but results are very surprising for a 3 years old technology.
Absolutely. And, you know, it's an important distinction that I represent the world of production and you real use cases, putting things up to run for days and hours and weeks and having things really be reliable. Whereas the gentleman to the left and right of me come from the world of research where they're at the complete cutting edge of what's possible. And those two things are colliding on stage here today. Excellent. So we have some videos here. Let's see if it plays back. Fernando, walk us through what we're looking at.
Yeah, what we want to show here on the left is the original footage to create an F, to create an F. You can see that's just a video walking on this corner of the house. On the right, we saw the NEF being used in an actual virtual stage powered by these guys on Plateau in Barcelona. And you can see that the way from going to the left, from the left video to the right one, is just uploading this video to our platform Bolinga, waiting for an hour, and you got that running on your stage.
The nice thing here, and we'll go through this in the virtual production section, is when you put a Nerf up on a volume like that, you're getting parallax. And I know it doesn't sound like a big deal. It's a huge deal if you're shooting in camera because it's gonna look real. Our eyes are so susceptible to the lack of parallax that when we look at content made that's flat, immediately something breaks and we think it's fake. So having that little bit of parallax is going to make all the difference in a production. All right, and then let me go to the next slide here. Yeah, Orlando, walk us through what we're working on and what can be improved.
Yeah, for the application of Nerf in virtual production, we see two important challenges here. I'm going to start with the second one, is relighting. So once you capture, you learn, or the neural network learns the pixels, you cannot tell, at least in principle, the neural network to render the pixels for an arbitrary position with a different illumination. That's really a huge drawback, that you cannot change the illumination. It's giving you a realistic illumination. So for challenging environments where the light is behaving really in a complex way, it's a great way of capturing that behavior. But then you cannot change that behavior. You cannot change the light source. That's confusing for creators and artists and people accustomed to 3D. But we are working on and researching on how we can do that change in the lighting. So we can tell the neural network, for example, we provide an environmental map, a different one from the one that was during capture, during filming, during capturing. And then to tell the neural network to render that the camera with a different environmental map. We are working on that research, and as many other researchers.
Yeah, so for example, if you capture the Hollywood Hills during the day, but your production says we need golden hour lighting, we could hopefully do that very soon.
Yeah, exactly. That's one of the things and flexibilities that we need. I think we didn't say so at the beginning, but it's very important to understand also that this is getting really popular, not only because it's really fast to create a model, but because we capture complex behavior of the light. So transparencies, reflections, and these kind of things. And to capture a complex behavior of a complex scene and to render it in Unreal Engine is going to take a lot of time, different professionals. First, to take out the light, and then to add the light and to simulate the light in the rendering engine, which is very interesting, and it will pose some philosophical questions, I think, in the future. We are like extracting the light, and then we are simulating the light currently.
Yes.
But with Nerf, it is not like that. The neural network is learning how the light is behaving, so it's going to imagine how the light is behaving from any perspective. So Nerf is very convenient for situations where you cannot use photogrammetry, where replicating the behavior of the light is very, very difficult. So that's one of the, I think, best advantages of Nerf right now.
Awesome. And then Fernando, talk us through from a production perspective, because we are up against, other types of content. So color spaces matter, dynamic range, bit depth, all those things matter. What are we working on there?
Exactly. I think in the previous talk, Kimball from Weta make a really good point. Machine learning is used to work with PNGs, JPEG, but we at the media and entertainment industry, we don't work with that. We use EXR files. So there is also an effort that has to be made. It's not that research, but it's more an industry effort to standardize all these pipelines using Nerfs, make Nerfs use EXR, high dynamic range images, color space. I believe this is going to happen pretty soon. We are working on it, but still there is some limitation there at this current moment.
Right. So, for example, if you throw up a Nerf on a volume and you shoot it in camera, then how do you know that that is Direct 2020, for example?
Right now, you won't probably know.
Yeah. So that's the area of improvement that we need to, and I'm sure that problem will be solved. Excellent. So, switching gears now, we have this incredible new tool. It's being perfected and dialed in. And how is this better than some of the tools that we have? And as technologists and creatives in here, we're all after the latest and greatest tools to make our lives easier. So here's a graph that I'll have Fernando walk us through.
Yeah, basically, I think this is a pretty graphical example on how much work you have to do with Nerfs. Compared with traditional 3D modeling or photogrammetry, the existing pipelines, with Nerfs, you just have to capture the data. We're going to go through it later, but it will take 5 minutes, 10 minutes being really slow. And then you will have to wait just 30 minutes, 1 hour for processing. You can also make it longer if you want higher quality. But in this case, once you have done this, you're done. I mean, you have an embol file ready. Embol, by the way, is the file we are using for Nerfs right now. And you're done. You have something that you can put on your state and look photoreal and have parallax. So it takes a matter of an hour, 2 hours, compared with maybe weeks of the other pipelines.
Yeah, and the important thing here is the amount of people that are touching this, right? With photogrammetry, you have maybe one person that captured it, another person that's the solve artist, and then another person that's optimizing. With 3D modeling, right? Imagine building a real world, let's say downtown LA. Each and one of those buildings are being modeled, brought in, textured, shaded, then lit. So that's probably 50, 60 different artists. This is very use case specific. So if you're recreating a sci-fi environment, obviously Nerf is maybe not the right choice. You're gonna have to build everything from scratch anyway. However, if your shot calls for just downtown LA as it is today, I think Nerfs is an excellent choice there.
Sure.
Right?
Actually, all of the examples that we're going to see and the examples we have shown was captured by only one person and sent to a studio. That's all.
Yep. And then let's get into some of the inner mechanics of a Nerf. So there is sort of a best practice guide, and we have the experts here. So walk us through it.
Yeah, I think one of the key takeaways of this talk that we want you to have is how do you start capturing nerfs and how do I create a nerf? An important and critical point of nerf creation is data capturing. So it is really similar to photogrammetry. So if you are used to capture data for photogrammetry, you can apply all this knowledge. But summing up, the most important thing is avoid blurry regions, either because of motion blur or either because you have focus regions. And also always search for parallax. Don't stop what you are capturing. Don't pan the camera. Just move around the objects and look at the one object from different point of views. Then using a fair amount of images, 80, 100 works, make the nerf work, and also using high resolution. It doesn't have to be ultra high, like 4K or 8K. 180 is already good, but yeah, don't go to, I don't know, 720.
Yeah, one of the good examples there is I was building a Nerf and I was using my red Komodo, and it's always set to cinematic, right? It's always set to 24 and 180 because that's what I always use it for. And I captured a Nerf, and the resulting frames were just a little too blurry, and it just resulted in a terrible Nerf. The minute I switched the red Komodo to 120 at a lower resolution, it was like night and day difference.
I like to see this from another perspective, more machine learning. And yeah, with any machine learning model, you need to you need to train it with high quality data. So a perspective to see this is that we need to try during capturing, when we are taking the pictures or the video, we are taking samples of those pixels that the neural network is going to be trained with. So we are trying to capture the highest quality. And actually, there is very interesting research about how to move the camera, how to best sample that space regarding, perhaps I don't take all the pixels of all the cameras for training or where to position the camera. And that's a very interesting research. But think about, you are taking data for the machine learning to train, to learn the pixels, and then to generate the pixels in the future.
Absolutely. Okay, we have some videos here.
Yeah.
Just play it and walk us through it.
Sure. What we wanted to show here is some examples of nerfs you can take right away when you go out from this talk, and you can just use this video, upload to Bowling, and you will get a high quality nerf. This is one of the first example. I think everyone should start doing this as a nerf, and it's orbiting around 360 in an object. So focus on something of interest, for example, in this case, this statue, and do 3 different heights with a video like I'm showing here, the 360, so the full turnaround of the object, and it will turn in a pretty good nerves. We'll see the quality later.
Yeah, always start with, be object oriented, no pun intended, rather than environment oriented for your first Nerf, or it'll be a little bit difficult of a learning curve.
Exactly. Another good example. Okay.
Let's see.
Another good example is capturing a wall. Graffiti looks crazy on nerves, and it's just similar, doing 3 different tracks, 3 different lines at 3 different heights. And that actually looks pretty good. We will see it later, but yeah, you can see the original footage on the right. I didn't take a good care here, but you will see that the result is pretty cool.
Yeah, in general, if you're translating yourself in space, the more you were translating it, the more parallax you're generating. So that's exactly what you can.
And you can see that no stabilizer is required. I mean, I just walk in here. You can see my
Yeah,
steps.
and that's the whole thing. If your camera is set to a high enough frame rate, or you're taking stills, you know, stabilizing it should not matter because you're really going after a single frame.
Sometimes it may look counterintuitive, especially for people with experience in photogrammetry, because what we're trying to avoid here is images that the neural network will find problems with because ambiguity or because from its perspective in the way in which the neural network learns. So the takeaway here is that don't think much about the reason why a certain movement is better. Obviously, we need to get that those good practices from academia and from practitioners, but don't think much about this is better because something. It's because the way in which the machine learning model is trained. So, yeah.
Yeah, absolutely. Just keep practicing, I think.
Yeah, you will get a good
Yeah.
intuition if you do some nerfs.
Or you can email Fernando. All right. One more. Okay.
Okay. Let's see if this loads. Well, what I think we should been seeing here is how to capture an interior, a room, which is usually a tricky example because everyone wants, since you are searching for details, everyone's go through the walls and go pretty close to the walls of the interior. But what you should do is put your back in the wall of the room. Imagine there is, or if there is a school, but imagine there is an object on the center of the room, and you just keep orbitating the room 3 different heights with your back in the wall, and yeah, it will turn out pretty well. Now we can see. Okay, we have some internet.
We have some network. There's a lot of people on the Wi-Fi.
But these pixels, well, this is still, for example, this one is the render nerf. So this is not actually the footage I saw before.
Yeah.
We can see it there. Yeah.
So again,
Okay.
just as versatile inside and outside and so on. So one thing to note here is nothing is moving. And that's really important to understand. Nerfs are not moving nerfs just yet. They're a moment in time representation of the real world.
The snapshot.
Yeah, again, in academia, I mean, there is also some research about dynamic nerf, and it works. The problem with dynamic nerf right now, the scientific methods, is that they are not real time. So you cannot render in real time. So for picture production, if we want movement, we couldn't render in real time. But in the future, in the near future, I hope next year, Bolingo will be able to deliver dynamic nerves and to render those in real time. But that's going to be awesome. And that's going to be a huge difference with respect to conventional 3D, because you are going to be able to capture not only the light, but movement, all kind of dynamism in that scene with the same easy.
Awesome. So we talked a little bit about the best way to capture nerfs, what nerfs are, some of the limitations, what we're working on. So we're diving right into the way it is today. How can we use it? So it's already being used quite a bit. So talk us through this example.
Yeah, this is a great example from Gloria Turner. Follow them on Twitter, and he basically has like a really cool 360 to nerf pipeline, and he just captured this using 360 images and create a nerf of this whole environment in just 1 hour, and going a walk around with, I think he's using an Insta camera. I think
Insta360.
Yeah. This is basically the result you can get from the examples.
Something that we can say also is that you don't need to use videos. It's just a video is just a convenient way of capturing frames and pictures. But you need to extract frames, certain keyframes from that video in order to train the neural network. But the capturing process based on the use of video is much better.
Yeah.
Better in the sense of easier for you.
Absolutely. Yeah, whatever is your workflow, use it. If you're a photographer, be a photographer.
Yeah.
The neat thing here is if you go to the middle of the video, you could see that Bolingo also integrates really nicely with Unreal. And if you're familiar with Unreal, you can use Sequencer to drive the camera how you want. So it's being treated like a 3D environment, even though there is no geometry or mesh. So that's the insane part.
Exactly, you can see it here.
Yeah. So that's in Sequencer. That's somebody, keyframing the cameras where it needs to go. And again, it feels like that environment exists in Unreal, but it really doesn't.
Yeah, the challenge that in Bolinga we had to overcome had to do with the real-time rendering. So again, you train the model, but now you need to render it. You need to render all the pixels of the image 24, 30 times per second. And you need to run the model, the neural network, several times to get a single pixel. So it's a different kind of neural network when you run it. So it doesn't give you the full image in a single run. You need to run it several times. So that needs a level of parallelism and a way of computing this in an efficient way, completely different to conventional.
Yeah, it's almost like a ray tracing pass. Like you can increase or decrease the number of iterations. Yeah, but again, apples and oranges, right?
Yeah, actually, it uses ray marching from computer graphics. Bolinga is, as Fernando said, a mixture of machine learning and computer graphics. So,
Here is one of our favorite users, Ian Messina, who is at Studio Lab in New Hampshire. This is a Disguise stage and big Disguise user and Volinga user. One of the early users of bringing environments into a volume. So that's a Nerf on their stage being used.
Yeah, exactly. That's how we can see the parallax here.
Yeah, you could clearly see the parallax even through an iPhone there. And again, that's the whole promise is you're recreating a 3D environment, so you get the inherent benefits of a 3D environment. All right, talk us through this one.
This is a really cool one. This is one of uses. Okay, I'm going to tell you when nerf in, nerf out. And basically what he wanted to do here is we wanted to do this drone shot, but we don't want to crash any drone. We want to
you can't put a drone through a tight indoor corridor.
Exactly.
So this drone shot was simulated with Nerf, and then with clever editing, you edit it in with regular video footage.
Exactly.
Yeah. So again, you give the tool to creatives, they'll figure out all types of ways to use it. And one more here. Okay, so this one, shout out to Jason at NVIDIA for handing us these. So Google has their own Nerf solution for indoor spaces. And I believe they're using it now for Google Maps.
That's it.
Yeah, so 5-6 years ago, if you're using Google Maps, you go into like a mall, you have no idea where you are inside that mall. So now they're figuring out how to do indoor location tracking with this. And location scouting, super important for production, as you know. So you already have the set of images somewhere stashed already. You can just feed them through Volinga and generate this, or you can go out and shoot it.
Exactly. Or ask your scouter to generate a nerf for you.
Yeah. Okay. There's more. Here's another neat example of location scouting. You know, your production asks you to go to Italy and recreate Italy, and you take a bunch of photos, you bring it back, and now you can have this walkthrough done by whoever. Again, this is all done in photogrammetry before, nothing groundbreaking there, but the interesting thing here is the number of people involved, the number of hours needed is just so much less.
Yeah.
I would say here that there is a lot of work to do from you guys, from professionals, to figure out how to use this tool, because we don't know yet the killer application and the killer use case within virtual production. If you think about it, you can use it for previs, you can use it for virtual scouting, you can use it in different stages in your production, even in post-production with batch rendering. So there are many possibilities, and well, we are working with our customers, of course, users, to figure out where it is most profitable to use Nerf. And I think this is an exciting moment for professionals to embrace a new tool and to check it out.
Yeah, actually, one of the cool things we are seeing is that, for example, in this case, when you push nerfs, let's say, too hard, and you go
Yeah.
really, really
Think
hard,
right there.
yeah,
Yeah.
there are people also using this for artistic content, like
Yeah.
using these artifacts that Nerf creates, which are called floaters. They use them for in a artistic way. We are developers, so we don't have this.
They look like a
ability.
watercolor to me. It's like
Yeah.
a Monet. Yeah.
Yeah.
So creatives are using the artifacting to their advantage. All right. And then next example. Okay, so this is a big one for industry use. When you're training autonomous driving models, those AI models, they need to be trained on as accurate of a representation of the real world as possible. And right now, a lot of the training is done in like a game engine like Unreal. So you'd have to recreate San Francisco in Unreal and then have your autonomous vehicle drive through that digital city and learn how it behaves. It's actually way simpler to just capture San Francisco, or it's already captured somewhere, and just feed it through a nerf, and now you have all of the depth perception, the parallax that's needed for self-driving vehicles. So this is right from Waymo, and again, Jason at NVIDIA sent us this.
Yeah, in NVIDIA, they are doing really cool research on combining conventional 3D graphics with Nerf in order to create a simulation of all those edge cases that the car may encounter.
And notice all the parked cars and any sort of distractions are removed on purpose. So this nerf was edited, and that's because that's what the autonomous vehicles can handle at the time. So it's AI feeding AI. All right, now switching gears into virtual production and Nerf. So I'm just going to walk you guys through this one. This is sort of the slew of tools we have available here. And each one of these tools have their time and place and when that's flexed. For example, like I was saying, you're building a beautiful sci-fi environment. You have no choice but to really invest in a heavy, beautiful Unreal scene because you're going to need to modify it and create it in a very creative way. But if you're recreating a real world and it's only needed for one shot and you don't have that big of a budget, I think a Nerf is an excellent option. Driving plates are used all day long for virtual production. As a matter of fact, I would say it's the #1 use case for an LED volume, the unsung hero of VP. Driving plates could be used as is, or it could be fed through Valinga and it could generate a Nerf.
That's it, and you don't have to fight with the camera calibration for hours.
Yeah, driving plates is actually really interesting because you already have a different vantage points. So typically, and I see Greg in the audience, we have a driving plate expert right there. So you have 9, 10, 11 cameras that are looking at different parts of the road. You can feed those different perspectives right into a Nerf engine. And 2.5D, for those of you who don't know what 2.5D is, it's layering. It's almost like layers in Photoshop and creating almost a faux parallax. So again, I talked about the importance of parallax. So when you have a significant camera move and it appears flat, your eyes will break it apart and it'll look fake. In those instances, it's best to have 2.5D, so multiple 2D layers, so you get that artificial parallax. And in a lot of instances, you can mix and match these things. So you can have a Nerf all the way in the back, and then you can have a 3D object in front of it, and so on and so forth. And yeah, just to touch on driving plates. So we already have terabytes, petabytes of driving plate footage all over the world. It's all still good. It's still usable. It can get fed right in through a Nerf engine. And if you're recreating a real location, Nerf is an excellent use case there. With the quality that we're achieving today, it's already, I would say, usable. And as Nerfs increase in resolution, have less artifacts, it's only going to get better and better. And the last thing, so in the world of broadcast, there's always a need for augmented reality objects that the presenter interacts with. And most of those times, those AR elements are built by an artist, so like a football player or a graphic or so on. Those things could easily be captured using a Nerf, so a very quick Nerf pass to get that object into your platform and then overlaid on top of your broadcast.
Yeah, for example, I think in a football player, you can use that camera rig that we are seeing
Exactly.
back there,
Yep.
capture the football player, and you have it there.
Yeah, just feed it through a Nerf engine, right? All right, Orlando, talk us through what's coming down the pipe.
So we didn't say anything about this part when we spoke about the things that we are working on, but this is editing. So the idea of, and the fact is that we need to create new mathematical tools to manipulate these primitives. And this is a little bit mind-blowing because in 3D graphics, we have had 40 years of research and development to develop all that background and techniques. But for Nerf, we need to research those. And one of the things that we are figuring out is how to edit the radiance fields to do transference style, for example. That's what we are seeing here. But also to move objects around, to change the color of objects, to enlarge objects. So all those tools that in our 3D environments we give for granted, that are already there, we are researching that and we are implementing it into new tools and putting them in the hands of the professionals. But this is a very cool research.
I think there might have been a question. I think I saw somebody raise their hand. Was there a question? Questions? Okay.
Well, Jess, we're going to get to questions in like a few minutes.
Okay, great.
If that's all right.
Yeah, no problem.
So, Fernando, walk us through the recoloring stuff.
Yeah, as Orlando said, we have to develop new tools to do recoloring, for example, in Nerfs. There are some cool works. I think this is from Adobe. Still a lot of work to have to be done, but we can see that we are getting there.
Yeah.
This is only a 3-year technology, 3-year-old technology. Let's wait and let's see what we have in a year. Also for the edition, this work is from INRIA, Institute in France. Again, you can see how now we can start modifying the objects.
I mean, it looks like there's vertices, but there really isn't.
Yeah, exactly. That's what it's all like.
Yeah.
We are trying to simulate these vertices.
Regarding the edition, we will be using, or one of the promising paths here is to use machine learning diffusion models to edit these radiance fields. So the same kind of technology or machine learning models that we use for text to image or text to video are going to be used, or we expect that that's going to happen for getting text to Nerf or for editing, in painting or out painting Nerfs. So, but again, Nerf is a primitive computer graphics that those other methods are going to change and generate and edit.
Understood. All right. Where was that question? Let's get to it.
Yeah, I'm curious, what's involved in installing one of these on a VP stage when it comes to camera tracking, calibration, scaling, and all like that?
Yeah, great question. So Disguise handles all those things you just said. So we have a central platform where the camera tracking data comes in, color profiles get loaded, spatial calibration, lens calibration, and so on. So you have this base platform that is now powering the stage. Check. How do you get a Nerf in there? You download an NVOL asset from Volinga right into Disguise, and that Nerf goes directly into that server. Yes, sir.
I have like two simple questions. So first one, similar workflow with photogrammetry, and you mentioned the how you take the imagery. Is there any issues with certain kind of compressions with the file, or is it what works in photogrammetry will work in Nerfs? Is that good solid
That's
so I
it.
can future-proof all the stuff I'm shooting?
Exactly. That's it. If it works in photogrammetry, it will probably works on Nerf.
And then how does a model done in photogrammetry compare to a Nerf, say, as far as performance? Like for somebody that does a lot of virtual reality work, how do those two compare? Is it super hard for a computer to render a Nerf versus what's the compare and contrast of those two?
Yeah, that's an interesting question. Basically, right now we are working and researching towards real-time rendering on Nerf and having better performance. Right now, you have to have a powerful GPU, NVIDIA GPU, to work. That's why we see virtual production and audiovisual production filmmaking as one of the first use cases of Nerf. In photogrammetry, you can easily, let's say, create models that you can run on virtual reality. You have to work on it, you have to optimize the model, but the thing is you can optimize the model. In Nerf, what you capture is what you get. That's really cool because you have reflections, you have complex materials and complex light conditions, but now you cannot optimize the model, or you can just optimize it a bit, and it still requires a bit of research to make this run on a mobile phone, for example.
Perhaps I can complement this. We need to think that we right now, nowadays, we have a software stack and a hardware that is really optimized for moving polygons and for managing textures and for doing everything specific to the current 3D technology that we have, but we don't have the same stack, mature one for Nerf. So that's something that we are doing in Polinga. We are optimizing the software stack to run Nerf efficiently on GPUs. But in the future, we will have for sure cores specific for Nerfs and perhaps a replacement for CUDA, perhaps, and a specific for those cores. So we have here like a fight, between this baby that is trying to get into this complex technological environment and something that is already there, which is a 3D meshes and conventional technology that runs very efficiently. And yeah, photogrammetry, you basically reconstruct and you translate the reality in meshes and in textures. So and now you have that software that is really optimized for moving that. So that's going to be one of the challenges in the short term.
We have one more question back here.
Thank you all for being here. I had a question about the previous 360 video example. Can you tell me exactly what software you used for that?
You mean the one that was generated using 360 images?
Exactly. I think you said it was an
Yeah.
Insta360 camera.
This is from Great Eterna. I can tell you a little bit, but I don't know the details. I think he used Metashape or Agisoft to just unwrap the 360 images from Insta360, and they treat it as individuals. I think 8 different normal images. And then he just fit this into Bolinga, the pipeline of Bolinga, and it works. So the thing here is how you turn these 360 images into, let's say, normal images. So I think he used Agisoft, but I cannot say for sure.
Right. So basically just feeding equirectangular projections into
That's it.
tangent. Gotcha. Cool. Thanks.
We have one.
More? Okay, one
We
more.
can take one more.
Actually, I had one question over here.
Yeah, go for it.
Trying to wrap my brain around how exactly the images incredibly elaborate lookup table for each camera position. Looks like this. Is that at all on track?
Right. So I'll just repeat the question a little bit. So how is all of the information, video, photo stored on a Nerf solver?
So yeah, that's the idea mainly. So, but the neural network is going to learn those pixels and it's going to approximate the pixels that didn't see. So it's like you can see it. Actually, this is the same technique that researchers are working on to compress images or to compress videos to learn things. And then the neural network is going to approximate things that didn't see. That's why also that's an important feature of this representation is that it's really, really compact. So independently from the complexity of the environment, you are going to have the same number of parameters for your model and the same number of bytes and the size.
Yeah.
And you can reduce it in 2 orders of magnitude the size of the files that you need to use in comparison with conventional 3D.
So, for example, I did a Nerf around the block that I live in. It's like 140 megabytes. It's not much.
Just a quick follow-up. Have you ever considered, or do you do a photogrammetric pass on a Nerf in order to establish geometry for some particular region that you want to manipulate?
Yeah, I think that one of the things that we and the academia are trying to do, like understand how to best use existing tools for extracting geometry to combine it with Nerfs. Because now once you have the 3D geometry, you have to translate these changes that you do to Nerf. And that is the, let's say, the hard part mathematically.
We're all outside there, so please come ask us questions. We are out of time. I want to respect PSLA. Thank you very much for attending.
Round of applause. So who now understands what a Nerf is?